Okay, welcome everyone. We have well over 30 participants, so hopefully anybody who hasn't joined us yet will join us shortly. My name is Dr. Angela Zabel. I'm first going to start with a welcome to country, and sorry, not a welcome to country, an acknowledgement of country. And if you want to explore what the difference is, because it's really important, you can ask me a question afterwards. So I want to acknowledge the Wurundjeri people of the Kulin Nation, who are the traditional owners of the land that I'm presenting to you from. I want to acknowledge their elders, past, present, and emerging, and of course, the care that they have taken for the country right across time and, of course, ongoing. I'd also like to acknowledge the traditional owners on any of the lands that you come from now. I'm not sure if we've got people from overseas, but of course, we have traditional owners all over the world, not just joining in from Australia. And I'd like to acknowledge and pay my respects to any traditional owners that might be joining us today. Welcome to Indigenous Astronomy, Light Pollution and the Shared Wilderness of the Night Sky. Thank you very much for joining us as alumni and stakeholders. The Faculty of Science actually has more than 40,000 science alumni, which is an enormous number, I know, and we're very proud of our students and our alumni. We want to stay connected, especially in this slightly disconnected time, and we want to be able to share our research and our news all over the world with our alumni. And so we can't meet in person, but it's lovely that we've been able to do a few of these events across the year. I am an alumni myself. I'm an alum from Monash Chemistry. You might wonder why I'm introducing an astrophysics talk, essentially. Well, I actually work quite closely with Krystal on several projects, one of which was the new Indigenous science unit that Monash launched this year. And that actually started the conversation that led to the talk. So Krystal has been helping me understand the amazing stories that come from astronomy and the first peoples from all over the world, and the amazing role that skies play in their oral traditions and in the everyday lives of Australia's first people, both previously and continuing today. I might have said I'm a chemist, but I have a sustainability interest too. So I guess my first exposure to the concept of light pollution is more from an ecological sense as opposed to an astronomy sense. Just to introduce the School of Physics and Astronomy for those of you who don't know much of the research, the School of Physics and Astronomy is a leader in imaging with light, X-ray and electrons, and in using world-class imaging facilities like Monash's Centre for Electron Microscopy, the New Horizons Centre and the Synchrotron Radiation facilities to carry out their research. The school hosts the Monash Centre for Astrophysics, which is a very diverse astrophysics research group that some of you may know about or can learn more about now. And the School of Physics and Astronomy has also established the Monash Centre for Atomically Thin Materials, which is a very important new area of research. So that's focused on transformative technologies such as graphene-based electronics, getting much more into chemistry there, so that's much more my chemistry area, and of course room temperature superconductors. Just before we actually start the presentation, a little bit of housekeeping. Q&A will happen after the presentation, so to get your questions asked, please use the Q&A function at the bottom of your toolbar during the presentation. Remember to upvote your favourite questions, and our alumni manager, Claire O'Grady, will be standing by to manage those questions and chats to make sure the most popular questions get through. We'll try to get through as many as time permits, of course. So to quickly introduce Michael and Krystal, if they want to turn their cameras on. Thank you. Krystal, who I mentioned, works with me. She's a student currently, just finishing up her undergrad. Krystal de Napoli is a Gamilaroi student in astrophysics and is researching the ways in which her culture and scientific interests intersect. So that's a fascinating area for me. Krystal is also working on a couple of books and has a long-running interest in science communication. So you might see Krystal speaking publicly elsewhere. And Krystal has been a great addition to our new unit that I mentioned before, but also we're building an Indigenous science website together to help other tertiary educators. Associate Professor Michael Brown, welcome. Michael is an observational astronomer at Monash's School of Physics and Astronomy. He specialises in multi-wavelength studies of galaxies using large telescopes all around the world. Now, we were just talking about the large, and I'm not going to use the right technical words, the large array, the large detector that just collapsed, that you may have seen spectacularly filmed in the news recently. Obviously, he's not currently using that for his research. I will hand over to Michael and Krystal.
All right, pleasure to be here. Let me bring up my screen in just a second. All right, and I hope everyone can see my slide presentation now. So it is a pleasure to be here at the end of this tumultuous year to discuss Indigenous astronomy, light pollution, and the shared wilderness of the night sky, illustrated here with this beautiful shot of the Milky Way taken at the European Southern Observatory, of which Australia is has a partnership with at the moment. And it's also a pleasure to be presenting this with Krystal, who I had the pleasure of teaching in ASP 2011 and ASP 3231 a couple of years ago. So one of the key themes that I want to convey for this talk is that the night sky is very much a visual experience, something that you can experience with your own eyes unaided. So there's roughly 5,000 individual stars that can be seen with the unaided eye. And there's then beyond that, the faint glow of the Milky Way, which is coming from billions of stars that we can't individually see. And we can see the Milky Way stretching across the sky from Sagittarius through the Southern Cross out towards Orion. Beyond our own galaxy, you can see the faint glow of stars in other galaxies, the combined light of stars in the Andromeda galaxy, 2 million light years away, and the faint glow of stars in the Magellanic Clouds, satellite galaxies of our own galaxies. And we can see the night sky changing. So on any given night, we can see the stars appear to rotate in the sky around the celestial poles, which we now recognize as the rotation of the Earth around on its axis. And at particular times of year, we can see different stars are up high in the night sky, which we can now recognize as resulting from the motion of the Earth around the sun. So for example, in the middle of winter, Sagittarius is high in the sky, whereas when we get around to summer, in the middle of the night, Orion is high in the sky. We can also see the night sky changing throughout the year or across many years. The planets, the wanderers, move relative to the fixed stars. We can see Mercury, Venus, Mars, Jupiter, and Saturn with the unaided eye quite easily. Uranus can slip in there at a bit of a, if you know exactly where to look and you've got good vision. And then beyond that, what we have, what we also have are visitors to our night skies. So for example, there are shooting stars, which you can see on any given night, but there are regular meteor showers and sometimes even meteor storms. And there's also less frequent visitors like comets, novae, and supernovae, which might appear every few years, or in the case of supernovae, perhaps every few centuries. And all of this we can experience visually, and indeed, cultures across the world have experienced it visually themselves over millennia, and it's informed those cultures in various ways. So planetary motion is very much a strong visual aspect of astronomy. So a classic example of that is Venus is sometimes the evening star and Venus is sometimes the morning star, which reflects the motion of Venus and us around the sun. Various cultures have produced models of the motion of planets around the sky, including models which make predictions about when, say, eclipses, etc., might happen, or conjunctions. So, for example, in Western culture, in Europe, the Earth-centered Ptolemaic model prevailed for many centuries. And while it gets a bad rap, it should be said that the Ptolemaic model had a lot of merits. It could predict the positions of planets, typically with an accuracy better than a degree, although it did tend to fall over a bit on Mars. And the Ptolemaic model was very much based on visual observations taken with the unaided eye, perhaps using a sextant or a giant protractor effectively to measure the positions of planets in the sky. The sun-centered Copernican model that was developed by Nicholas Copernicus was designed to provide a more intuitive mathematical model of the solar system, but actually included very little new data in constraining this revolutionary model. It still used many of the observations that Ptolemy had used centuries before. Even Kepler's laws of planetary motion, that a planet moves in an ellipse around the sun, that a planet sweeps out equal area in equal time as it moves around the sun, that the period of a planet's orbit squared is proportional to the distance of the planet from the sun cubed. Those laws of planetary motion were in fact informed by visual observations. Tycho Brahe's visual observations of planets which had unprecedented precision were in fact not taken with a telescope, but were taken visually by Tycho Brahe, unaided, with effectively a giant sextant to measure the positions of planets to a small fraction of a degree. While in the Copernican revolution, Galileo's telescopic observations and his persecution by the church feature prominently, those telescopic observations which observed the phases of Venus as it travels around the sun, that discovered the moons of Jupiter, those telescopic observations were confirmation of the Copernican revolution. They weren't actually the starting point of it. The starting point of the understanding of planetary motion was actually based on visual observations, people with their own eyes observing the planets in the sky. That visual aspect continues on in many aspects of astronomy. So, for example, comets are very much a visual experience, and if you've had the good fortune of seeing a comet, a bright comet with the unaided eye, it's unforgettable. Comets that are visible to the unaided eye turn up every few years to every few decades if we're a little bit unlucky. And we now know that these are dirty snowballs that are heated by their passage close to the sun. The ice is melted and evaporates on the comet, and the dust is launched into space as well. And we can get tails stretching millions of kilometers across the solar system. And so from Earth, we can sometimes see tails stretching tens of degrees across the sky. Those tails are actually not sort of something that you can really appreciate with a telescope, which takes this very close focus view rather than a broad sweeping view. And so, a comet at its best is often a very visual experience seen with the unaided eye. And I can certainly remember seeing Hyakutake back in the 1990s with a tail that stretched about a quarter of the way across the entire night sky. While some comets pass by infrequently, only returning to the center of our solar system after millennia, others do return more often. And the most famous of these comets that return relatively frequently is Halley's Comet. Halley did not discover the comet that bears his name, but instead, through hard work and understanding Newtonian physics, recognized the periodic return of that comet. So while the 1682 observations of Halley's Comet were by Flamsteed using telescopic observations, the earlier apparitions of the comet that Halley used to understand its periodic motion and return were visual observations by Appianus in 1531 and by Kepler in 1607. So Halley's work, which was one of the early and most outstanding triumphs of Newtonian physics, while it was in the telescopic age, actually was very strongly connected to visual observations taken by observers at dark sites with their own eyes without any aid whatsoever. So while astronomy has very much moved on from being purely visual observations, we've moved on to radio waves, such as at the Arecibo telescope, which unfortunately collapsed recently, and also famously collapsed on Sean Bean and GoldenEye back in the 90s. We've moved beyond the visual. We've moved to radio, we've moved to X-ray, we've moved to infrared, what have you. We've even moved to astronomy beyond light using neutrinos or famously gravitational waves coming from colliding black holes. While all of this is part of the contemporary astronomy landscape, astronomy still remains a visual experience, a science that you can visually experience in a way that you can't with some other sciences. You know, you can go out and you can see the stars if you have clear skies. You can see Venus in the morning or in the evening, and you can see that planetary motion at work. You can see stars change with the year, that's seasons. You can see the Milky Way, the galaxy in which we live, stretching across the sky. And you can see shooting stars and meteor showers and comets and novae and supernovae. And you can appreciate the planets with a small telescope in your own eye at the eyepiece. You can see the rings of Saturn. You can see the moons of Jupiter. You know, you can see the ice caps on Mars. So this is very much something that we can all experience for ourselves. And it's something that makes astronomy connect with many people around the world. Unfortunately, however, over the past century, our experience of astronomy has definitely been changing. And that's perhaps illustrated by this photo here of the Melbourne skyline. As a civilization, we've been building up lighting, and that light affects our view of the night sky. If you have a clear night in Melbourne, near the CBD, you might be only able to see tens of stars, not thousands of stars. And this is because the stars, the fainter stars, are lost in the light pollution that comes from the CBD. And even in the suburbs, you'd struggle in many of the suburbs to be able to see any sign of the Milky Way, although you can see the brighter stars within the Milky Way. Beyond that, there's also some new threats to how we view the night sky. This image here shows a very large star field. The star at the bottom of the image here is Arcturus, which is quite a bright star. And we can see here two satellites, which are part of Elon Musk's Starlink communication satellite constellation. And this constellation of satellites, just in and of itself, is going to multiply the number of satellites in low Earth orbit by a factor of several. There's going to be somewhere in the order of 10,000 of these satellites, and other low Earth orbit satellite constellations are planned. This large number of satellites in low Earth orbit could potentially, unless mitigated, impact our view of the night sky. There's a genuine risk, if we're not careful, that in the early evening or in the pre-dawn skies, that our view of the night sky will always have some artificial satellites in view. And so we'll lose that sense of pure wilderness that we have with the night sky now. And this would be an impact that would happen regardless of where you are on the globe. Indeed, for some latitudes and some times of year, it's possible that the satellites would be visible throughout the night. So this is a very serious concern about how we connect with the shared wilderness of the night sky. So a real concern for astronomers now is that the night sky has been sort of a shared universal wilderness for millennia. It's been part of many cultures for millennia, but perhaps it's going to be fundamentally changing. You know, the night sky has often been the starting point for science, a natural inspiration, a natural thing to explain. Seasons, time, planetary motion, cosmology often have their origins in our visual observations of the night sky. So what happens if that experience is lost? How do we experience astronomy if we don't have that natural connection with the night sky? What if the night sky is reduced to a few bright stars? What if our view is always contaminated by a few artificial satellites? And what if that connection with science becomes less natural and always has an artificial element involved in it? Does that lost wilderness become an issue? So at this point, I think it's probably a good point to hand over to Krystal, who's going to introduce an Indigenous view of the shared wilderness of our night sky.
Awesome. Thank you very much, Michael. That was, a fantastic introduction. And I really like the point of highlighting how something like a comet is something that it is, I guess, easier to appreciate in a visual experience. So that if you're actually using a telescope, you actually do lose something instead of, a hyper clearer image of it. So I just think that's a really nice point to make, so that even though we have technology that's always improving and increasing, there are experiences that we have that sometimes are just best left when they're in their most basic natural form. So my name's Krystal Napoli. I've been introduced before, so I will jump into things. I'm going to share my own presentation and talk you through a bit of it. Okay. Hopefully that should be showing right now. Sort of hard for me to verify, but anyway. So I'm here to talk about some Indigenous astronomy and give that, I guess, like the cultural heritage point of view of why the preservation of the night skies is very important, or at least in my eyes. So I do a lot of work in the field of Indigenous astronomy. Research with science communication is such a massive part of it, and that's to just try and educate people on a more truer and accurate history of Indigenous knowledge and culture. Indigenous science is something that tends to be historically overlooked, and that's why I'm so excited to be a part of the changes that Monash University has made in terms of creating this Indigenous science unit and making it accessible to as many students as they can. And I think that this is something that will hopefully just keep expanding in the future through all universities as well. To give some background on Indigenous culture, at least here in Australia, I think it's important to highlight a few things. And so we are said to be home to the world's longest continuing culture. This is on a scale that is just so hard to comprehend if we are thinking in terms of colonization over 200 years ago, being Australia's more recent history. When we start to think about the timescales of Indigenous culture going 80,000 to over 100,000 years in length, it's something that it's just hard to wrap your head around. And we can think of all the, all the historical events and that we attribute to the last 200 years. You can imagine just how much history and knowledge has been packed and has evolved over that timescale. So to highlight as well, I've loved to include this map. It's a map of the approximately 250 different language groups of Aboriginal languages here in Australia. And you can use that as a rough approximation of the different countries that are here on this continent. And so I think that's an important thing to distinguish as well, that these are 250 different languages, not 250 different dialects. We do have around 700 different dialects. And so these language groups, you can think of them as countries that are as diverse as any countries in other continents. So if you were to compare in Europe, a place like Germany and Italy, the different cultures, the different languages, that's the level of diversity that we see here on this continent between different groups. There are similarities and there are a lot of stark differences as well from neighboring communities. Another important point, which most people are probably already aware of, is that Aboriginal culture here is an oral culture. And so this is common for a lot of Indigenous cultures preceding the written word. So this is a culture which thrives on encoding and transmitting information and knowledge through thousands of generations without relying on a written textbook or writing this stuff down. And sometimes it can be hard for people to wrap their heads around, particularly if we have that Western bias, where it's hard for us to think of how we would trust this information to be transmitted accurately. And yet this is what we see. And so we can think then if we have 60,000 or plus years of a world's longest continuing culture, we get a really long record back, or a really long look back into history of the things that have happened here on this continent, and of the way that this information has evolved over time. So to begin, so I just wanted to highlight them before never mind, I'll jump ahead. It's so weird talking to a screen. Sorry, I'm so used to doing this in person. Not seeing people's faces is a bit jarring. So I wanted to highlight what we risk losing when it comes to light pollution and cultural heritage in the skies. And this is a comparison that I love to highlight, where if the skies are our library, our books are the stars. To expand upon what I mean by this sentiment, knowledge in Indigenous culture is usually encoded into oral traditions or stories. And so a lot of these stories people tend to be familiar with in a way that they've heard about, the rainbow serpent, or have been taught some sort of story in, say, primary school or in passing. And we tend to think of these, or tend to be taught them, as though these are these mythical stories that are just sort of some fantasy to enjoy. But actually, a lot of these stories are encoding information and are using the characters and the features as a way of symbolizing the information. So an example I love to give is if I'm trying to encode information about the sun and the moon, and the way the sun and the moon move across the sky and the way that they sort of interact, I can tell a story about a sun woman and a moon man. And it simplifies this concept, and it enables me to be able to encode different layers of complexity into it. So if I want to talk about the way that they pass along the sky, and I can say that I want it to be that the moon man is following the sun woman across her path, I can tell that story to a kid of the moon man following the sun woman. But if I want to get into some complexities about the way they move, I can talk about relative speeds, I can talk about their movements, the moon man zigzagging away from the sun woman, talking about how the moon is sometimes above or below the sun's path, which is the ecliptic. So there is thousands of examples of the way that we can take a story and we can encode layers of meaning, and we can reproduce it at different levels of complexity, depending on who we want to educate. So a lot of these stories have their reference points in the sky. So these stars, these features, a lot of them, which I'll highlight in a second, they're essentially the books. They are the reference point for a knowledge tradition, looking at the Southern Cross, for example, and knowing all of the information about maybe a particular community's calendar that relates to the movement of the Southern Cross, the information we need to know for navigation. You can encode a lot of meaning and relate it to a constellation, because it's not just a story you have to keep in your head now. It is something that you can see in your landscape, and it is easier to, I guess, trigger that memory. So if we start to obscure our library, if we start to have this increase of light pollution, we are able to see less of our stars and our features, we are starting to lose our books. And so this is why I find it really important to look into dark sky preservation. So I wanted to give a couple of examples of what I mean in terms of how we can use features in the night sky as a library or a reference of sorts. I wanted to give the emu in the sky up first, because this is a very popular example. Anyone who's seen my talks before probably knows this like the back of their hand at this point. But it is a great example of how you can use a feature in the night sky to encode many layers of knowledge. And so here we have 4 panels of the emu in the sky. And the emu in the sky is essentially where you'd find the Milky Way. So the bulge of the Milky Way makes up the emu's body. We have the Coal-Sack Nebula for the emu's head. And if you go to a dark sky region, you're going to see the shape. And I love it because, to me, it actually looks like an emu. So it's a constellation that I can actually see and understand a lot more than some of the obscure ones that I've grown up learning. So the emu, if we look over here, we have this panel A. This is the female emu who is running for a mate in autumn. And so this is the start of the emu breeding season. And this is around the time of year that, at least the tale that I'm talking about, which is a Gamilaroi perspective, but it's very similar to a lot of different communities right across the continent. They would know this is the time to collect the emu eggs. There's also not obviously, but there is a focus on sustainable harvesting. So making sure that you're only taking enough eggs that you need and enough to let the life cycles continue. If we look over at panel B, this is in winter, so around June, July. And what we are seeing is the Milky Way, or the emu in the sky, sort of heading downwards. And this is said to be the male emu sort of sitting down to roost over the emu eggs. So at this time of roosting, this is actually when chicks start to form in the eggs and when people would stop collecting them. Panel C, this is representing springtime and this sort of perpendicular angle that we get with the horizon and the Milky Way. And then in panel D, this is around summertime. And what looks to be the tail of the emu sort of lowering itself down into the waterhole of the horizon. And this lowering itself of the waterhole is said to displace the water, used as a descriptor for the dry, arid conditions of summer. Then we will start back up in panel A in autumn to continue the cycle of the emu. So you can see from this one story, we are looking at a feature in the sky and we have different layers of knowledge that we can encode. So it's telling us about the emu behavior, it's talking about the seasonal change with also the water source changing in terms of its availability. It talks about our food source of the emu's eggs and also highlighting sustainable harvesting. And this is a very simplified version of this one story. And there are many, many others just like it. So you can see the different layers that we can encode. I wanted to highlight some other features in the sky which are very vulnerable to light pollution. Because for example, like with the emu in the sky, we can't see the Milky Way in Melbourne. In my hometown, I can if I head a few minutes out of town, and I'm lucky for that. But a lot of people haven't seen this before in their lives. And yet it used to be a common universal experience, and not just here in Australia, but in different Indigenous communities around the world, attributing their national birds to seeing the same pattern. So the Magellanic Clouds as well, they pop up in quite a lot of different astronomical traditions for Indigenous communities. They're regularly seen as birds or cranes or brolgas, and they're tied a lot to law and used as calendars of certain events throughout the year. And it's a bit sad that we are here on Kulin Nation land and they have traditions relating to the observations of these features in the sky, and yet we can no longer see them due to light pollution in the city. Comets, as well, as Michael Brown has discussed already, these also feature a lot in oral traditions of Indigenous, different Indigenous communities. They tend to be seen as sort of, so at least from what I've seen, tend to be seen as sort of like omens, highlighting taboos in society. Usually when you see one reinforcing like, you know, this is a reminder for us that we act in a certain way in terms of things like generosity, I know in the community, like not being someone who is very greedy with food and what's the word, like resources, just as an example. But also is tied to, in Gugu Yalanji traditions, it is tied to the rainbow serpent, some of their rainbow serpent traditions, which are tied to Halley's Comet, which is something that you periodically see every 75 years. And so for something like this to feature in Indigenous astronomical traditions, it's highlighting that longevity of the tradition and how encoding into stories and passing along is actually an accurate and safe way of transmitting information. And it's not included here, but I have given countless examples of traditions which have been passed along for way longer periods of time. Like 75 years is actually quite small for Indigenous astronomy. We have traditions which are passed along for hundreds to thousands of years. It's a fascinating field, and oral culture it's amazing how you can transmit information accurately. I have a short amount of time, which is why I'm sort of speeding through some things. So I also wanted to highlight a special feature in the night sky. This is found within the Southern Cross, which is arguably probably one of the most popular constellations in this country because it is on our flag, for Australian flag, and it is something that's quite unique to the Southern Hemisphere. So the Southern Cross, it has its fifth smallest star, which is known as Epsilon Crucis. And this star also has a lot of other significance because thanks to an IAU decision, I think a year or two ago, this star, this Epsilon Crucis star's official name, not its bare designation, which is Epsilon Crucis, its official name worldwide is actually an Aboriginal waterman name, Geenan. And so this star, or the word Geenan, is said to represent a dilly bag of knowledge. And unfortunately, this is one of the stars that is vulnerable to light pollution. If you go out and you try and look for the Southern Cross, this is one of the dimmest stars in that constellation. And it's a shame because this is something that's not just Aboriginal heritage here, not just a part of our constellation and our flag, but this is something that worldwide is attributed to this continent. Its name from this continent. And it's a shame that that's something that we're losing sight of in cities. Okay. The final thing I wanted to highlight as well is how we also have certain stellar observations from stars which feature in a number of astronomical traditions. For example, here, like the Pleiades. And I want to highlight, jumping back a few slides here. This is also a painting of the Pleiades. This painting you can find on the Australian Mint's Indigenous Astronomy series of coins that they have at the moment. This is the second coin in the series, and it is for the Seven Sisters, or the Pleiades. And these stars are used by many groups right across this continent as a calendar of seasonal change, and also relating to certain animal behaviors. And this is from, East Coast to West Coast. There are different communities with their own traditions. And this is a set of stars that's quite difficult to see as well, especially currently in Melbourne. And so there are certain aspects of, there are certain features in the sky essentially that we are losing to light pollution, which are really important signposts and reference points for a lot of Indigenous knowledge and Indigenous knowledge systems. Sorry for that speedy version, but that is what I will share for now, and I'm happy to answer any questions on the topic. Thank you.
Thank you, Krystal and Michael. We've got some questions coming through now. Let me see what Claire has sent us. So for both of you, I guess, what's happening in the night sky now that's interesting to you? I guess at this time of year, that means.
So perhaps I could lead off with that one, since I've been asked this question a couple of times recently. So the most interesting thing that's happening in the night sky at the moment is the conjunction of Jupiter and Saturn. They're very close to each other in the sky at the moment. And tomorrow evening, if it is clear, which is a bit iffy, the moon will be directly above Jupiter and Saturn. So you can see that in the early evening, a very thin crescent moon, and then Jupiter and Saturn below. And then a couple of days later, on the 21st of December, they're going to be so close to each other that it's going to be like a fraction of the width of the moon. And that's the closest that they've been to each other and observable with the unaided eye for 8 centuries.
Wow.
So if you were to look at those with a telescope, you'd be able to see both planets together, both planets' moons, the clouds of Jupiter, the rings of Saturn in one telescopic view. So that's going to be something that I'm certainly looking forward to.
I definitely have the same answer as well. The Saturn and Jupiter kiss is very exciting. So,
well, it's once in 800 years.
Yeah, pretty rare.
Yeah.
More than once in a lifetime.
Not planning on seeing that again. Okay, question 2. So this is from someone who is asking, if I had an interest in hearing more about astronomy and about Indigenous astronomy, where should I go?
So we have a website for Indigenous astronomy, which is an excellent database resource of majority of the resources that are out there related to this field. And so you can search via community, search via content. You can see information about different elders who have contributed to the research. And so it is simply www.aboriginalistronomy, in one word, .com.au. You can visit there and find out more information. And we also, as mentioned before, Angela and I are working on an Indigenous science database. It is for tertiary institutions. I don't know how much we can actually promote about that just yet because it's still getting polished off.
Yeah, it's mostly for educators wanting to teach about Indigenous science, but certainly it has a strong astronomy page.
Yeah.
But the astronomy page has a strong overlap to that Aboriginal astronomy page too. So that's a good place to go.
Yeah.
Okay, so from Elaine, how do we manage the issue of light pollution? Is there anything we can do?
So I'm happy to sort of start with that one. So there's a number of things that we can do. And one of them is, turn off the lights that you don't need, close the blinds, etc. The other is better lighting in the outdoors. So if you have a look at a lot of modern lighting, street lighting and lighting often around the Monash campus as well, you'll see that the lights are kind of boxy, and that's so that the light that comes out from those lights is all directed and reflected downwards, rather than the more traditional, sort of circular lights, which throw a lot of their light upwards. So there's certainly things that we can do to mitigate light in cities, and that should improve things with time, but it is still an issue. I think also for industrial applications, there needs to be a lot of care taken thinking about light as well. So for instance, there's a lot of people trying to push along, say, fracking in rural areas in Australia, and they often have gas flares associated with them, and those gas flares should be shielded appropriately.
Yeah. That's a really good point as well. There is currently a movement of Gamil means no, not to promote, but I will, like fracking that has been approved across Gamilaraay country, and this is quite close to dark sky heritage areas, particularly is it Warrumbungle National Park near Coonabarabran Siding Springs Observatory, where a lot of this fracking has been approved, and this is it's not only leading to issues in light pollution but also environmental destruction. So this is light pollution. It's like an interdisciplinary issue that you can definitely have a lot of people from different areas come together to try and solve, because it's it affects animals, it affects Indigenous Australians, it affects the lighting industry, and you can really and astronomers, and so you can really come all together and come up with a solution. But yeah, as Michael said, smart lighting choices, directed lighting, minimizing spill, all those sort of moves.
If people want to influence or attempt to influence groups or individuals, is there a particular way of targeting and getting that? It's pretty hard for an individual to influence what a new industrial site sets up. What are the ways of influencing people?
So I think, there is the International Dark Sky Association, which does identify issues that affect the night sky and tries to coordinate on these issues. There's a lot of design standards that come out in Australia, some of which are related to light pollution. And often it's a case that some of those standards are mandatory, but others are more sort of recommendations rather than being mandatory. And obviously tightening up some of those design standards so that they're actually mandatory rather than merely strong suggestions would obviously help matters considerably. So talking to politicians, etc., lobbying, informing various inquiries on various regulations would be a key part of that.
Question 4. Can you give an example of a phenomenon that spans several generations between sightings and an associated Aboriginal or Torres Strait Islander story used to keep that knowledge alive?
Yeah, so an example which highlights longevity of oral traditions is it's a Yolngu story, so that's up from Arnhem Land, and it's a descriptor of, well, I'll highlight the story in a quick version because I think story is really important, and I don't usually like to separate telling about the knowledge without including the story. But it talks about two brothers who are going out in their canoe to go fishing and are struck by a pretty severe storm. And so their boat capsizes, and the older brother is able to save his younger brother, but is unable to save himself. And when they return, well, the younger brother returns back to his community and they ask what happens. He explains the older brother's sacrifice, and they perform a ceremony to commemorate his memory and his contributions. And it is said at the time of this ceremony that this bright star emerges in the banks of the Sky River, which is the Milky Way, between the pointers of the constellation Scorpius, between Shaula, Shaula and Lasath, which are the stars at the end. And so this is a very common sort of notion as well in Indigenous communities, because a lot of, instead of there being a massive focus on constellations as being the important thing, a lot of importance and significance is placed on individual stars. And usually for different communities, it'll be attributed to some important historical figure or member of their community. And so to see this bright star emerging after the brother's sacrifice, they instantly attribute it to being the brother's, the brother essentially having passed up into it's sort of like the afterlife. It's hard to explain, but it's sort of like that creation, the creation story relative to that community. So what's interesting about this, the location of this particular star, is that this is also something that was seen by ancient Chinese astronomers, and they dated it in the year of approximately 2000. I've forgotten the specifics, and they think that it's a supernova occurrence. And so if this happens to be the same object, it's a great example of a story that has been passed along for 2000 years. There are other stories which stretch back around 10 to 13,000 years regarding a specific placement of stars in the sky, because as astronomers know, we have our sky has this, well, our Earth has this precession cycle, and so our view of the night sky changes over this cycle of about 26,000 years. And so 13,000 years ago, you're looking in a different part of the sky than what you are now. And that's just because of our axis and how we're spinning around it. It's sort of like a spinning top where it slowly changes where it's facing. And so we can use these features and geological features that are described in the stories to link up and date back the age of certain traditions. And so, for example, this is one that has a very long age. And then a final example is there are different descriptions of fire falling from the sky as well, in particular in sort of central areas, communities. And this fire from the sky is what we think to be something like a meteorite falling. And what's interesting is you can take these stories from these communities and essentially go out into these areas and have found meteor crater impacts as well. So then we can try and date them back. So there's different ways you can try and validate the longevity of these oral traditions. Yeah.
Thanks, Krystal. A quick question back to the light pollution. Does the use of LED lights, has that made any difference?
I don't think it's made a massive difference. There's some pros and cons with the use of LED lights. So for instance, for amateur astronomers, they can use a sodium filter to reject light from sodium lights, those distinctive orange lights, whereas a lot of the LED lights now have a much broader, white spectrum. So, that's sort of a negative for amateur astronomers with telescopes. And obviously the LED lights can be a lot brighter in some instances. I think it's probably on average a bit neutral. The LED lights can be somewhat brighter, but then also they're often used with the proper housings that let less light up into the sky. So we'll wait and see, I guess.
Okay, thanks, Michael. Next one is from Kim to Krystal. With such a diversity of Indigenous peoples, do they still share their stories of the sky today?
Yeah, definitely. So although effects of colonization have been pretty devastating, a lot of this knowledge is continuing and still existent. So it's good to think about Aboriginal culture not as some past thing, but as still the world's longest continuing culture. So a lot of this information stories still belong in community and also belongs in written records since colonization. And what's interesting is a lot of these stories will tend to be quite similar based on location as well. So you can see that there is this information exchange between groups over time. And one thing I like to highlight as well is the multilingual nature of Aboriginal groups, particularly before colonization. It was very important to be able to trade and communicate with different communities, and these trade networks were very vast and can spread across from one coast to the other coast. And so to be able to do that sort of trade, you would need to be able to communicate in different languages. And so to be fluent in, like, say, 5 or more languages apparently was quite common prior to colonization, because there is just this crazy diversity of different languages around you. And usually you would learn a lot of that knowledge in those languages. So there is still ongoing information, and there is a fascinating way of it being exchanged.
Thanks, Krystal. I'm not sure how many questions we have time for, but there's certainly at least one more left. In regards to teaching the concepts in, say, the high school setting, what do you recommend in terms of ensuring that we are doing so in a respectful and appropriate manner? I'm assuming this is in regards to any Aboriginal and Torres Strait Islander stories.
Yeah, so I think an important thing is, I know that there was updates to the curriculum in the last 2 years that were driven by a large working group to make sure that there were modules available at years 5 and year 8 for teaching Indigenous knowledge. And I know that the people who worked on these things wanted to make sure that the amount of resources and information they had included was enough for people to be able to communicate about these topics effectively, because I didn't want to scare any teachers off away from feeling they couldn't touch these topics. So I would start with a lot of those curriculum modules, even if you're not in that same year level for year 5 or year 8. It's probably a really great resource to help give that information along. And I know that there are also there's been a lot of work into looking into how to most respectfully deliver this type of information in the classroom as well. So Angela, do you remember? I know this is the sort of stuff that we do include on our website, because we want to aim it at teachers to make sure educators can engage with this content in a way that they feel comfortable with and supported with. And
and that's why we needed a new website. So the curriculum material is at the Australian curriculum level, so that then has to be adapted to each state's. I actually find those government pages, super hard to navigate, but I promise, excuse me, there is maybe in excess of 120 examples, and hopefully if you have experience, you're an experienced teacher, you can get all the bits and pieces you need off that website. I can't speak highly enough of a short course that's available at the CCCA, which is the Centre of Cultural Competency Australia. It's run by Aboriginal and Torres Strait Islander people, and they have developed a something like 10 or 12 hour set of modules that you can just sign up and do online. There is a fee, I think it's about $190, and you get access for 6 months. I think that was really good, and it gives you a great basis. If you're looking for something which is just getting familiar with some background concepts and some ways to speak and relate professionally, I guess, and respectfully, then the series, The First Australians, is a documentary series that's often on SBS and is an amazing resource. It's about 7 hours. The material won't necessarily be suitable to show students, but it's fabulous for giving basic competency for teachers in that space, or anyone. We use it with our students. Okay, last question. Is there anything happening in the world of astronomy right now that you're excited about? More specifically than the one in an 800 years event? Is there new inventions? What are we doing in astronomy that's really exciting?
It's a great question, that it's a sort of a, how long is a piece? How long is a piece?
Give us a couple each.
So I think a big theme that's been happening with my colleagues at Monash that's really exciting over the past 5 years or so is the growth of astronomy beyond light, exemplified by the detection of gravitational waves from merging black holes, and the discovery of those gravitational waves, the Nobel Prize for those gravitational waves, the discovery of new black holes being formed, of black holes merging together. And so that's been probably a huge theme at Monash in particular over the past few years. But there's so many other things that spring to my mind. You know, looking at planets in formation, again, something that my colleagues at Monash are very much involved in, where you can now, with the ALMA telescope, see such detail that you really can see these protoplanetary disks and the planets forming. And then I think the third one that I'll sort of highlight is the new facilities that are coming online. There's the James Webb Space Telescope, which is going to be launched in the next year or two. That's going to be amazing for my work. The Australian Square Kilometre Array Pathfinder, which is producing data right now. And that is going to open up the radio astronomy sky for Australian astronomers in a way that hasn't been possible before. And I'm really looking forward to getting students involved, getting their hands dirty in that data. Hopefully Krystal included in that contingent of students mucking around with that exciting new radio data.
Fingers crossed.
Krystal, what about you?
I would like to highlight from an Indigenous astronomy perspective, just how I know over time a lot of this information has felt very inaccessible, and I've been asked over the years as well about things like books. It's particularly for things like kids, for them to be able to read something and engage with this sort of information in a way that is a lot easier to understand than some of the more archaic stuff that we have. And so I just know a lot of people in this field who are producing things like children's books. For example, Corey Tutt, who is the amazing creator of Deadly Science, which is a fantastic initiative of getting not only just books to Indigenous students across Australia, particularly in remote communities, but like telescopes, amazing scientific resources, and getting kids enthused. I know he has a children's book coming out. I have one that I'm working on in the future. I know that there's academic textbooks, and there's novels that are aimed at kids or teens and young adults. So I think that I'm excited about a lot of that in terms of accessibility, in terms of knowledge sharing that's about to occur. So yeah, that's mine.
Great, thank you. There's no questions left, and we have literally got 30 seconds to a minute left. So thank you very much, all of the alumni that came and joined us today. I hope that you learnt some fascinating facts about astronomy and the night sky. Thank you, Krystal, and thank you, Michael, for joining us today. And thank you for our wonderful administration staff hiding in the background there, Claire, Michaela and Udi, for organising everything, for wrangling both Zoom and the questions and the crowd. I'm sure you were very well behaved. Thank you very much, and we will see you at the next alumni session that you come to. Thank you.
Thanks, Ange.
Thank you, everyone.